Alex, many philosophers, theologians will absorb all these fantastic theories of cosmology explaining the universe and say, we agree with it, we understand that, but science alone cannot go past the why question. They can explain the how, but never the why, and they always come back to why the cosmos. You can never explain it. You, however, have come up with something very interesting called quantum tunneling. And I'd like to understand how that works.
Okay. So maybe I want to step back a little bit because what started me thinking about these issues is the theory of inflation that was introduced by Alan Guth. And Alan came pretty close to explaining where the universe comes from, because he showed how the entire observable universe and much more can come out from a tiny speck of space filled with what is called false vacuum, which is the gravitational repulsive stuff that causes the space to expand at very high rate. So, but the question remains where this initial tiny speck come from. So this is a little piece that needs to be filled in.
Some people say it's a very big piece that needs to be filled in.
Philosophically speaking, it is very big indeed. What I was thinking about is how could inflation start? To have inflation, you need this false vacuum. So suppose we have a universe, a closed universe, which is filled with false vacuum. And suppose we also have some matter in it. Now, if we contract the universe to a small size, matter will dominate and the universe will collapse. If we expand it, matter will be diluted and the vacuum will dominate. Its gravitational repulsion will take over and the universe will expand and start inflating. So there is some intermediate range of radii in between, which is forbidden classically. According to classical physics, the universe cannot have that size. So what I thought is, okay, suppose you have a small universe which is filled with matter and vacuum. It expands because matter dominates, it recollapses, and that's the end of it. This will happen very quickly. But what I realized that there was another option. Instead of collapsing, this universe can tunnel through this barrier, quantum mechanically. Although this process is forbidden in classical physics, in quantum mechanics, particles, and for that matter, universes, can traverse this energy barrier and re-emerge on the other side. Say if you come to a Coke machine, a can of Coke, in principle, can come out of there by quantum tunneling. The probability for this to happen is very small, so I wouldn't recommend waiting.
And if we would wait from the beginning of the universe to now, the odds are extremely small that it would have happened even once.
That's right.
Right.
But the probability is not zero.
Yes.
That's the point. So that's a possible scenario. You have a tiny universe which expanded, but then instead of collapsing, it tunneled through the barrier and started inflating, and inflated ever since.
Let's define that barrier to be a little bit clearer. That I understand if you have matter in the small universe, the gravity predominates, it just compacts back, and it's the end of that story. But instead of doing that, what is the barrier that we're talking about?
Well, the universe will expand. It will expand if you give it a kick. Basically, you have a small universe, you started it expanding, it will expand a little bit, but then gravity of matter will stop the expansion and the universe will recollapse. In order for it to inflate, you need a bigger size so that the matter gets diluted.
Yes, yes.
Right? But it doesn't get there.
Right, right.
So, what I was asking myself, what size of this initial universe is actually needed? And I thought, what would happen if I decrease it and make it smaller and smaller? And what I realized was that the probability of this quantum tunneling through the barrier did not vanish, even in the limit of zero size. And even the mathematical description of the whole thing became much simpler and more beautiful. So basically what I had was a theory describing quantum tunneling from nothing, from the universe of initial zero size, tunnels through the barrier. So initially you had nothing, as close to nothing as you can get, because there is no matter, there is no space, there is no time as well, because nothing is happening. And what happens is that all of a sudden you have a small universe, a closed universe, which appears out of nowhere and starts inflating.
What you're saying is that as you took the small universe that collapsed and made it smaller and smaller, the tunneling still existed, but then when you went from very small to even zero, it was still there.
That's right.
And that seems like a huge step from however small to zero.
Exactly.
But that didn't change the capacity of tunneling to work.
That's right. You know, when you talk about creation of the universe, these are words, and at some point you're led by mathematics. So what the mathematics that I had is, I think it's most straightforward. If I put it in the words kind of in the most straightforward way, it would be to say that the universe is spontaneously created out of nothing.
Now, some could go beyond that and say your nothing has a lot of somethings in it. You have quantum mechanics, you have rules for tunneling, you have a whole bunch of things in your nothing that you sort of stuck there, which is not really nothing.
I agree. This is certainly not absolute nothingness in the sense that it is assumed that the laws of physics are still there. Wherever that is.
However they got there.
Right.
Or whether they were there forever or how they got there. But there was nothing tangible, no matter, no space, no time. The things that we call something.
Yes.
There were these principles or whatever that you are deriving from. But so what you're saying is that you have a physically consistent way of having a universe emerge from nothing under the current laws of physics as we understand them.
Right.
That's pretty impressive. How have your colleagues reacted to that?
Differently. You know, when I first gave a talk about this at Harvard, a friend of mine, Lawrence Krauss, came up to me after the talk and said, you know, it's amazing to give a talk like this and survive.
That no space, no time, no particles, no radiation, no laws. To me, that's a pretty good approximation of nothing. I don't care if there's a pre-existing entity. Our universe did not exist. It came into existence.